Hi students, welcome to Sankalp Learning Classes. In this session, we'll be discussing the 2 and 3 mark questions of chapter Application of Derivatives. We have already discussed the important concepts as well as 1 mark questions of the same chapter. So straight away, we are going to discuss the questions. So the first question is, find the intervals in which the following functions are: first one, strictly increasing, and second, strictly decreasing. Okay. So you will be given two functions. Okay, there are two questions in this. So you have to find out the intervals in which the functions are strictly increasing and then strictly decreasing also. Okay, so the first function is f of x is equal to x square minus 4x plus 6. So how will you find out the intervals in which a function is strictly increasing or strictly decreasing? What is the method? First, you have to find out the derivative of the given function, isn't it? That is f dash of x. And if this f dash of x is less than 0, then we can say that the function is strictly decreasing on that interval, right? If dash of x is less than 0, then we can say that the function is strictly decreasing on the given interval, isn't it? And if f dash of x is greater than 0, then we can say that in that particular interval, the function is strictly increasing, isn't it? So first we have to find out f dash of x. So what is f dash of x? The derivative of x square minus 4x plus 6. The derivative of x square is 2x. And derivative of minus 4x is minus 4, right? And derivative of 6 is 0. So what is the derivative of dash of x? It is equal to 2x minus 4. All right. Now what you have to do is that put f dash of x is equal to 0, which implies 2x minus 4 is equal to 0. That implies 2x is equal to 4. So x is equal to 4 by 2. That is equal to 2. So x is equal to 2. So which is a critical point? X equal to 2 is the x equal to 2 is the critical point, isn't it? Now what you have to do, you have to so we know that since f of x is a polynomial function, what will be its domain? Domain is a set of all real numbers, right? Set of r or open interval minus infinity. Infinity is the domain of the function, since it is a polynomial function. Okay, so at x equal to 2 is a critical point or turning point, which means the nature of the function is changing at that point. Okay, nature of the function is changing. Okay, something is happening to the function at the point x equal to 2. Okay, which means x equal to 2 is the point that divides the domain of the function into two parts, isn't it? Minus infinity, infinity is the domain of the function, but since x equal to 2 is a critical point, there is a change in the nature of the function, which means x equal to 2 is a point that divides the real line into two intervals. Which are those intervals? They are minus infinity comma 2, and the next interval is 2 comma infinity. Okay, so these are the intervals. Now what you have to do is that we have got the interval. Now we have to check in these intervals what is happening to f dash of x, and thus that means the sign, you have to evaluate the sign of f dash of x. Thus we'll understand what is happening to the function in that interval, that is the nature of the function, isn't it? We'll understand the nature of the function. Okay, so for that, consider a point in between minus infinity comma 2. That is the first interval, right? So consider a point in that interval. 0 is a point in that interval, right? So what is f dash of x? F dash of x is 2x minus 4. So you put x equal to 0. Now what happens? That is 0 minus 4. It is equal to minus 4, right? It is equal to minus 4. Minus 4 is less than 0. Minus 4 is less than 0. So what is the sign of f dash of x? F dash of x is less than 0 in that interval, isn't it? Now, consider the interval to infinity. Okay, take x is equal to 3. X equal to 3 belongs to that interval, right? And now what you have to do? 2 into 3. Isn't it? You have to put x equal to 3 in 2x minus 4. So 2 into 3 minus 4, that is equal to 6 minus 4. Isn't it? 6 minus 4, that is equal to 2, which means it is greater than 0. From that you get f dash of x is greater than 0. F dash of x is greater than 0 in that particular interval. Isn't it? So what can you say from this? In the first interval, f dash of x is less than 0. F dash of x is less than 0 means, f dash is less than 0 means it is strictly decreasing. Okay, now in the second interval, f dash of x is greater than 0, isn't it? So what do you mean by that? If f dash of x is greater than 0, we can say that the function, the nature, what can you say about the nature of the function? It is strictly increasing. It is strictly increasing. So we have got the intervals in which the function is strictly increasing as well as strictly decreasing. Which is the interval in which the function is strictly increasing? It is open interval to infinity. And which is the interval in which the function is strictly decreasing? It is nothing but open interval minus infinity comma 2. Alright. Now we are moving on to the next question. That is a sub part of this question. Okay. So the next function is f of x is equal to minus 2x cube minus 9x square minus 12x plus 1. So this is our function f of x. Minus 2x cube minus 9x square minus 12x plus 1 is our function. Alright. And what is f dash of x? F dash of x is equal to, what is the derivative of x cube? It is 3 into x square, isn't it? So minus 2 into 3x square minus 9 into 2x minus 12, isn't it? The derivative of x is 1, so it is minus 12. So this is equal to minus 6x square minus 18x minus 12. So this is our f dash of x, isn't it? Now, you can take minus 6 outside, isn't it? Minus 6 is common in all the three terms, so we can take minus 6 outside. So this will become minus 6 into x square plus, if you take minus 6 from 18x, it will become 3x, right? Plus 3x, then minus 12. So take minus 6 from that. So this will become plus 2, isn't it? Now you factorize it, x square plus 3x plus 2. What will be its factorization? Minus 6 into x plus 2 into x plus 1. Right? So 2 plus 1 is 3 and 2 into 1 is 2. So x plus 2 into x plus 1. Right? Now what you have to do, you have to get the critical point. So f dash of x is equal to 0. Put f dash of x is equal to 0. So this implies minus 6 into x plus 2 into x plus 1 is equal to 0. Which implies x plus 2 equal to 0 or x plus 1 is equal to 0. Isn't it? So that is x is equal to minus 2 and x is equal to minus 1. So which are the critical points of this particular function? Minus 2 and minus 1 are the critical points of this particular function, which means the nature of the function changes at the points minus 2 and minus 1. Okay, and again, the given function is a polynomial function. So its domain is a set of all real numbers, which means in interval it is minus infinity, comma infinity. And these critical points divide the interval, divide the real line into 3 intervals. Okay, divide the real line into 3 intervals, isn't it? So here you can see that it is minus infinity, infinity, and the critical points are minus 2 and minus 1 will be here, right? Which means how many intervals are there? How many intervals are there? This one is an interval, minus infinity, comma, minus 2. Then minus 2, comma, minus 1. It is another interval, right? Then 1, comma, infinity. Okay. So there are 3 intervals. Now what you have to do? You have to check whether the function is strictly increasing or decreasing in these 3 intervals. Okay. So that is the next step. So first we'll write the intervals. And then what we have to check? We have to check the sign of f dash of x. When you understand the sign of f dash of x, we can determine the nature of the function in that interval, isn't it? We can determine the nature of the function. Okay. So the first interval is open interval minus infinity, comma minus 2. And the second interval is -2 comma -1, and the third interval is -1 comma infinity. Okay, so these are the intervals. Now we'll check what is happening to f dash of x in these respective intervals. So first you consider the first interval -infinity comma -2. Take any point in that interval. Let's take -3. Okay, -3 belongs to -infinity comma -2, right? So you can check this in general also, because in -infinity comma -2 all the numbers will be negative, so you can actually, without substituting any points in that interval also, you can find out the sign of what is happening to the sign of f dash of x. Okay, this is also another method, that is, take any points from that interval and substitute in f dash of x, then you will check which is the value, so you'll get f dash of x is less than 0 or f dash of x is greater than 0. Okay, so here I'm taking -3 and I'm going to put in f dash of x. F dash of x is -6 into -3 plus 1, isn't it? X plus 2 into x plus 1. So -3 plus 1 and -3 plus 2. Okay. So this is equal to -6 into this one will be -2, and this one is -1 actually. So in total this is 6 into -2. -6 into -2, it is -12. It is -12. -12 is less than 0. So what is happening in the first interval? F dash of x is less than 0. F dash of x is less than 0. And in the second interval, it is -2 comma -1. You take any points from that interval. You take, let's take 1.5. Okay, -1.5 belongs to that interval, isn't it? -1.5 belongs to -2 comma -1. So what is happening to the sign? -6 into -1.5 plus 1 into -1.5 plus 2. Okay, so that is equal to -6 into, this is -1.5 plus 1, it is -0.5 into -1.5 plus 2, it is again 0.5, isn't it? So this is equal to, minus and minus gets cancelled. So the value is, this is 0.25 into 6 is 1.5, isn't it? So the answer is 1.5, which is greater than 0. So in the second interval, we have got that f dash of x is greater than 0. In the second interval, f dash of x is greater than 0. Now you consider the third interval, which is the third interval, -1 comma infinity. -1 comma infinity is the third interval. Take any point in that interval. 0 belongs to that interval, right? 0 belongs to -1 comma infinity. 0 belongs to that interval. And now you put 0 in that one, -6 into 0 plus 1 into 0 plus 2. So this is equal to -6 into -6 into 2. So that is -12, right? -12 is less than 0. So in the third interval, we have got f dash of x is less than 0. So what can you say about the nature of the function from all these? Okay, consider the first interval, f dash x is less than 0. It is strictly decreasing. It is strictly decreasing. Here, f dash of x is greater than 0. So we can say that it is strictly increasing. And in the third case, f dash of x is less than 0. So it is strictly decreasing. Okay. So now we have got the nature of the function in the respective intervals. All right. Moving on to our second question. So the second question is, find the local minimum value. Find the local minimum value of the function f given by f of x is equal to 3 plus mod x, where x element of R. Okay. So the function is 3 plus mod x. Okay. So what is mod x? Mod x, we know it is always greater than or equal to 0. Isn't it? For every x element of R. For every x element of R, modulus of x is greater than or equal to 0. Is that clear? Now, the given function is f of x is equal to 3 plus modulus x. Isn't it? F of x, we have to find out the local minimum value of this function. 3 plus modulus of x. Okay, here it is, since it is modulus function, we know modulus functions are not differentiable, right? We cannot find the derivative, so we have to find another method to find out the minimum value of this particular function, right? So that's why we are considering it like this. So f of x is equal to 3 plus mod x, and we know this will be always greater than or equal to 3 plus 0. Since the value of mod x is greater than or equal to 0, we can substitute the value there, right? So this will be always greater than or equal to 3 plus 0, which means this is equal to 3. From this, what can we understand? That is f of x is always greater than or equal to 3. Isn't it? F of x is always greater than or equal to 3, which means, what is the minimum value of this particular function? What will be the minimum value of this particular function? It is 3. 3 is the minimum value. For any other x values, the function f of x is greater than 3, which means what is the minimum value of the function? F of x equal to 3 is the minimum value of the function mod x plus 3. Okay, so what is the local minimum value? Local minimum value is nothing but 3. Local minimum value is nothing but 3. Okay, now we are moving on to the third question. Find the maximum and minimum values of the function. Maximum and minimum values of the function f of x is equal to x square when x element of R. So this is our function f of x is equal to x square. Okay, you have to find out the maximum as well as the minimum values of this function. You have to find out the maximum and minimum value of this function. Which function? F of x is equal to x square. So how will you do that? Again, from the graph, you can easily find out the maximum and minimum values, isn't it? Which will be the minimum value here? You can see that according to the graph, this is the minimum value, isn't it? It is at x equal to 0. What is the value? At x equal to 0, f of 0 is equal to 0, isn't it? Is there any other values which are less than 0 for this function? No. So x equal to 0, then f of 0 is 0. So that 0 is the minimum value of this particular function. What about the maximum value? So we have got the minimum value. Minimum value is equal to 0. What about the maximum value? Is there any maximum value for this? Is there any maximum value for this graph? No. Since x element of R, it can go up to infinity, right? The x can take up to infinity. So this graph is going beyond our imagination, isn't it? It's extending up. It is going up to infinity, which means does this function has a maximum value? Is the function stopping somewhere? No, right? If you restrict the domain into into intervals, smaller intervals, then we can find the maximum value, isn't it? But this one, it's going up to infinity, so we cannot say any maximum value for this function. So it has no maximum value, and the minimum value is nothing but 0. All right, now we are moving on to the next question. Find all the points of local maxima, and local minima of the function f of x is equal to 2x cube minus 6x square plus 6x plus 5. So this is our function f of x, that is 2x cube minus 6x square plus 6x plus 5 is our function. We have to find out all the points of local maxima and local minima of this function. Okay, you have to find out all the points of local maxima and local minima. So let's see, how will you find out local maxima and local minima? It's like actually by using first derivative test or second derivative test, right? So first we need the derivative of this function, that is f dash of x. F dash of x is equal to 2 into 3x square minus 6 into 2x plus 6, isn't it? This is equal to 6x square minus 12x plus 6. Okay. So we can take 6 outside. So this will become x square minus 2x plus 1. So this can be factorized as 6 into x minus 1 the whole square. This is the expansion of x minus 1 the whole square, right? X square minus 2x plus 1. Okay, so 6 into x minus 1 the whole square is our f dash of x. Now what you have to do, you have to put f dash of x is equal to 0. F dash of x is equal to 0, which implies 6 into x minus 1 the whole square is equal to 0. That implies x minus 1 the whole square equal to 0, which implies x minus 1 equal to 0. That is x is equal to 1. Okay, x is equal to 1. It is the only critical point. X equal to 1 is the only critical point. Okay, which means it divides the real line into two intervals, x minus infinity 1, and the second interval is 1 comma infinity, isn't it? Now what you have to do, we have to observe the sign of f dash of x. Okay, we have to observe sign of f dash of x, then we'll get the nature of the function in that interval. Okay, we'll get the nature of the function in that interval. Okay. So here minus infinity 1, you can see that f dash of x is equal f dash of x. What is happening to f dash of x in minus infinity 1? You put 0. Okay, 0 in that f dash of x. Then what is happening? 6 into 0 minus 1 the whole square, isn't it? So this is equal to 6 into 1, that is 6, which is greater than 0. Isn't it? 6 greater than 0. So here f dash of x is greater than 0. Now you consider any points from this interval. 1 infinity. Take 2. Okay. So this is equal to 6 into 2 minus 1 the whole square. That is again 6 into 1 square. That is 6 into 1, which is 6 greater than 0. So here also f dash of x is greater than 0. So from this, what can you understand? What can you understand from this, from the sign of f dash of x about the nature of the function? At 1 is a critical point of the function, isn't it? So we know that local maxima or local minima can occur at the critical points, right? But when you consider the first derivative test, if you take points near to 1, okay, if you take points near to 1, if the sign of the f dash of x is different in both sides, okay, then we can say that it has a local maxima or local minima. If both the sides of the point, okay, in the neighborhood of the point 1, in both sides, if the sign of the f dash is same, that is either f dash is greater than 0 or f dash is less than 0, we can say that that point is a point of inflection, isn't it? There is no change happening there for the function f. Okay, so we can say that that point is known as a point of inflection, isn't it? So here, which point is a point of inflection? X equal to 1 was our critical point, but we have understood that the sign of f dash of x is not changing in either sides of the point 1. Okay, in either sides of the point 1, we can see that the function is greater than 0, which means the function is not changing at the point x equal to 1, which means the x equal to 1 is a point of inflection. Okay, sign of f dash of x is not changing, so we can conclude that x equal to 1 is a point of inflection. So is there any point of local maxima or local minima for this function? No, because there is only one critical point, and that critical point is a point of inflection. So we can say that this function has no points of local maxima or local minima. Okay, now moving on to our next question. Find the absolute maxima and absolute minima of the following function. Absolute maxima and absolute minima of the following function. Okay, so f of x is equal to x minus 1 the whole cube, x minus 1 the whole cube plus 3. So this is our function, okay, f of x equal to x minus 1 the whole cube plus 3. And what is the question? Absolute maximum. You have to find out absolute maximum and absolute minimum. How will you find out absolute maximum and absolute minimum? First, we need the critical points. And then we have to substitute this critical points in the function, and we have to find out the value of the function at the critical points as well as value of the function value of the function at the end point. So we need an interval, right? So the interval is also given in the question. X belongs to -3, 1, which means we have to evaluate the function at x equal to -3 as well as x equal to 1, which are the end points of the interval. Isn't it? So first what we have to do, we have to find out critical point. So find out f dash of x. F dash of x is equal to, this is actually a composite function, right? In the place of x, you can see that it is x minus 1. Okay, so assume x minus 1 as x and then find the derivative as usual. So this is of the form x raised n. So this will be nx raised n minus 1. This is the derivative, right? So this is 3 into x minus 1 the whole square, but we have assumed x minus 1 as x. So we have to multiply the derivative of x minus 1 also. What is the derivative of x minus 1 with respect to x? It is nothing but 1, isn't it? It is nothing but 1. So this plus 0. All right. So this is equal to 3 into x minus 1 the whole square. Now put f dash of x equal to 0. Put f dash of x equal to 0, which implies 3 into x minus 1 the whole square is equal to 0. That implies x minus 1 the whole square equal to 0, which implies x minus 1 equal to 0. That is x equal to 1. Okay, x equal to 1 is a critical point. So we have got the critical point. Now what you have to do, you have to substitute this critical point in the given function in order to get the value of the function at the critical point. Okay, so f of 1 is equal to, f of 1 is equal to 1 minus 1 the whole cube plus 3. That is equal to 0. Cube is 0 itself. 0 plus 3, that is equal to 3. Now we evaluate the function, value of the function at the endpoints as well. So f of minus 3 is equal to minus 3 minus 1 the whole cube plus 3. So that is equal to minus 4 cube plus 3. That is equal to minus 64 plus 3 equal to minus 61. It is equal to minus 61. And what is f of 1? F of 1 is equal to 1 minus 1 the whole cube plus 3. Okay, that is 0 cube plus 3 is equal to 3. All right. So what is absolute maxima? Absolute maxima, we can take another page. So absolute maxima is equal to, absolute maximum is equal to maximum of f of 1, which was our critical point 1, right? F of 1, and the endpoints was f of minus 3 and okay, f of 1 we have already found out, isn't it? Just a minute. F of minus 3 and one endpoint was the one endpoint was 1 itself, isn't it? So we have already included f of 1 here. So no need to write again f of 1. So what is the maximum of these values? Maximum of 3. F of 1, I think f of 1 was 3, right? F of 1 was 3 and f of minus 3 is minus 61. Okay. So 3 and minus 61. So which is the maximum value here? 3. So which is the absolute, what is the absolute maximum of the function? 3 is the absolute maximum of the function. Now what is the absolute minimum of the function? How will you find out absolute minimum of a given function? It is nothing but minimum of the function, value of the function at the endpoints as well as the value of the function at the critical point. So here there are only 2 points, that is f of 1 and f of minus 3. Since endpoint and a critical point, there was only a critical point and the endpoint was also the same. So we need only two. We have only two data, that is f of 1 and f of minus 3. You have to find out the minimum of these, isn't it? Minimum of 3 and minus 61, which is the minimum value. It is nothing but minus 61. So what is the absolute minimum of this given function? It is nothing but minus 61. Okay. Now moving on to our sixth question. An edge of a variable cube a variable cube is increasing at the rate of, it is increasing at the rate of 3 centimeter per second. Okay, it is increasing at the rate of 3 centimeter per second. So how fast is the volume, how fast is the volume of the cube, how fast is the volume of the cube increasing when the edge is 10 centimeter long, when the edge is 10 centimeter long. Okay, so there is a cube and the edge of this cube is increasing at the rate of 3 centimeter per second. So let edge of the cube be x. Let edge of the cube be x. Okay. So they have given that it is changing at the rate of 3 centimeter per second, which means dx by dt is equal to 3 centimeter per second. And how did I wrote t? That is, how did I understood that it is, I'm going to differentiate it with respect to t, because here they have given it as per second. Per second means it is a unit of time. So you have to differentiate it with respect to t. Okay, so dx by dt is 3 centimeter per second. And how fast is the volume of the cube increasing when the edge is 10 centimeter long? So the edge of the cube is 10 centimeter. And at that moment, you have to observe that the rate of change in the volume of the cube. You have to observe the rate of change of volume of the cube. Okay, and we know volume of a cube is nothing but x cube, right? Volume of a cube is x cube. So you have to find out dv by dt, isn't it? dv by dt is equal to 3x square. dv by dt is equal to 3x square. So we are differentiating x with t. So into dx by dt. Isn't it? We can't stop there. If it was with respect to x, then we can stop at 3x square. But here we are differentiating x cube with respect to t. So the function is in x and we are differentiating it with respect to another variable, that is t. So you have to multiply its derivative also, isn't it? Since we are assuming it as the variable. Okay, 3x square into dx by dt. So this is equal to 3x square into 3, which means this is equal to 9x squared. So in general, the rate of change in volume with respect to t is 9x square centimeter cube per second. Centimeter cube per second. But they have asked you at the when the rate of change of the volume when x is equal to 10 centimeter, when the edge is equal to 10 centimeter. So you have to substitute the value of x here. Okay, 9 into 10 square, 9 into 10 square is equal to 900 centimeter cube per second. 900 centimeter cube per second. So this is the rate of change of volume with respect to t. Now, seventh question is find two positive numbers. Find two positive numbers whose sum is 15 and the sum of whose squares is minimum, and the sum of whose squares is minimum. Okay, you have to find out two positive number and such that the sum of those numbers should be 15 and the sum of the squares of those numbers should be minimum. Okay, so let x and y be the two numbers. Okay, x and y be the two numbers. X plus y. Let the function be x square plus y square. It is the sum of the squares of these numbers, isn't it? Let this be our function. Let this be s. Okay, I'm giving it as s, or you can give it as any f or any name. Okay, so here I'm going to give it as a name. S is equal to x square plus y square. So this is our function, and now what you have to do is that you have to change either x or y into the same variable. Okay, so here I'm going to change this y into x. Okay, so here y is equal to 15 minus x. So this can be can be written as x square plus 15 minus x the whole square. X square plus 15 minus x the whole square. That is x square plus 225 minus 30x plus x square. 30x plus x square. That is 2x square minus 30x plus 225. Okay, so this is our function. And what is ds by dx? We are going to differentiate this function with respect to x. Okay, so this is equal to 4x minus 30. This is equal to 4x minus 30. So what is d square s by dx square? D square s by dx square is equal to 4. Isn't it? D square s by dx square is equal to 4. Okay. Now, we have to find out the minimum of that particular function. Okay. So here I'm going to apply the second derivative test. Okay, second derivative test. So first we have to find out the critical point, isn't it? So what was our f dash of x? ds by, I'm sorry, ds by dx. This is our first derivative of the function, right? So that was 4x minus 30. So you put this one equal to 0, 4x minus 30 equal to 0 in order to find out the critical point, right? So 4x is equal to 30, which means x is equal to 30 by 4, that is equal to 15 by 2. So 15 by 2 is x. X is equal to 15 by 2. Now, in the second derivative test, you have to evaluate the second derivative, isn't it? So this is d square s by dx square is equal to, when at x is equal to 15 by 2, okay? X is equal to 15 by 2, it is 4. For any x values, it is 4, which means it is greater than 0. So f dash at the critical point is greater than 0 means, using second derivative test, you can say that the point x equal to 15 by 2 is a point of, it is a point of local minima, right? It is a point of local minima. Okay, x equal to 15 by 2 is a point of local minima. So what will be y? Since x plus y is equal to 15, y is equal to 15 minus x, that is equal to 15 minus 15 by 2. Okay, so this will be 30 minus 15 by 2, it is equal to 15 by 2. So what are the values? X equal to 15 by 2 and y equal to 15 by 2, isn't it? So these are the numbers. Okay, such that the sum is 15 and the sum of the squares of these numbers is minimum. All right. Moving on to our next question. Okay, so this is our function f of x, that is 3x power 4 plus 4x cube minus 12x square plus 12. You have to find out all the points of local maxima and the points of local minima of this given function. So how will you do that? First you need f dash of x, right? F dash of x is equal to 3 into 4x cube plus 4 into 3x square minus 12 into 2x plus 0. Okay, so that is 12x cube plus 12x square minus 24x. So this is f dash of x, isn't it? This is our function f dash of x. Now you take 12 outside. Then what will happen? X cube plus x square minus x 2x, right? 24 from 24, if you take 12, that is 2x, right? So this is our f dash of x. Now you can factorize this one. Actually, if you take, you can take x also. X is also common, right? So here, instead of taking 12 outside, you can take 12x. So 12, if I take 12x, the remaining is x square plus um, x, then minus 2, right? X square plus x minus 2, isn't it? So if you factorize this one, 12x into, so if you have to get plus 1 when you add and minus 2 when you multiply, right? So x square plus x minus 2. So we can take x minus 1 and x plus 2, isn't it? So minus 1 into plus 2 is minus 2. Minus 1 plus 2 is plus 1, right? So x minus 1 into x plus 2, isn't it? Now what you have to do, you have to find out the critical point. So f dash of x is equal to 0 implies 12x into x minus 1 into x plus 2 equal to 0. Which means if 12x is equal to 0, x is equal to 0, isn't it? Now, if x minus 1 is equal to 0, which implies x is equal to 1. Third part, if x plus 2 is equal to 0, then x is equal to minus 2. So which are the critical points? Which are the critical points of this particular function? X equal to 0, x equal to 1 and x equal to minus 2 are the critical points of this function. Okay, these are the critical points of the function. Okay, so and we need f double dash of x. Since if you have to apply the second derivative test, we need f double dash of x also, isn't it? F double dash of x is equal to our function f dash of x was f dash of x is equal to 3, I'm sorry, it is 12x power 3 plus 12x power 2 minus 24x. So this is our function. Again, you differentiate this function. So what will be the result? 12 into 3x square. 12 into 3x square plus 12 into 2x minus 24. Minus 24. That is 36x square plus 24x minus 24. Okay, so this is our function 36x square plus 24x minus 24. That is equal to, if you take 12 outside, then this will be 3x square plus 2x minus 2. 3x square plus 2x minus 2. So this is our f double dash of x. Now what you have to do is that you have to evaluate the values of the f double dash of x at the critical point. So first critical point is 0. So 12 into 0 plus 0 minus 2, that is equal to minus 24. Minus 24. And what is f double dash of the second critical point was 1, right? F double dash of 1 is equal to 12 into 3 plus 2 minus 2. Isn't it? So this is equal to 36. Now, what is f double dash of the third critical point was minus 2, right? F double dash of minus 2 is equal to 12 into minus 2 the whole square is 4. So 3 into 4 is 12 plus 2 into minus 2, right? So this is equal to 12 into 12 minus 4 minus 2, which means 12 minus 8. That is equal to 4, right? So this is equal to 12 into 4. 4 minus 2, actually it is 6. So 12 minus 6 is 6. So this will be 12 into 6. Okay. This 12 into 6. 12 into 6 is 72. 72. Okay. So if f double dash of c is greater than 0, we can say that c is a point of local minima. If f double dash of c is less than 0, we can say that c is a point of local maxima. So here it is less than 0. So 0 is a point of local, it is a point of local maxima. Less than 0 means local maxima. Now, this one greater than 0. Isn't it? F double dash of 1 is greater than 0, which means 1 is a point of local minima. Greater than 0 means local minima. Now, f double dash of minus 2 is greater than 0. Again, greater than 0, which means minus 2 is also local minima. Minus 2, the point x equal to minus 2 is also a point of local minima. And what we have to do, we have to find out all points of local maxima and local minima of the function. Now we have got the points of local minima and local maxima are x equal to 1, x equal to 0 and x equal to minus 2, isn't it? At x equal to 0, it is a point of local maxima, right? It is local maxima. So what is the local maximum value? Local maximum value is equal to f of 0. So you put 0 in the function. What was our function? Our function was um, 3 f of x is equal to 3x power 4 plus 4x cube minus 12x square plus 12. This was our function. So what is f of 0? Put 0, 0 plus 0 plus 0 plus 12. So what is f of 0? F of 0 is equal to 2. So what is the local maximum value of the function? It is 12. Now, local minima of the function. We have to find out local minimum also. So there are 2 points in which the function attains local minimum. They are x equal to 1 and x equal to minus 2. So at x equal to 1, the function is equal to 3 plus 4 minus 12 plus 12. Okay, so that is equal to 7, and x equal to minus 2. F of minus 2 is equal to, f of minus 2 is equal to 3 into minus 2 the whole power 4 plus 4 into minus 2 the whole power 3 minus 12 into minus 2 the whole square plus 12. Okay, so that is equal to 3 into minus 2 power 4, isn't it? So this will be 16 minus 16. Actually, it will be plus 16, right? Uh, Plus 16 plus 4 into minus 2 into minus 2 is plus 4. 4 into 2 is 8, right? So this is equal to minus 8 minus 12 into 4, that is 48, right? So minus 12 into 4 is minus 48 plus 12, right? So this is equal to, so the value will be 6 into 3 is 18, 48 minus 4 into 8 is 32, minus 48 plus 12. So this one gets cancelled, minus 32 plus 12, right? So that is equal to minus 20. That is equal to minus 20. So we have got local minimum values also. They are 7 and minus 20. They are 7 and minus 20. Isn't it? Now, we are moving on to, so we have got the local maximum value of the function also and the local minimum values of the function. Okay, now we are moving on to the next question. Okay, so the length x of a rectangle, it is decreasing at the rate of 5 centimeter per minute. Okay, so length is x. Length is x. It is decreasing at the rate of 5 centimeter per minute, and width is y. Okay, so width is y. That is the second data. And it is increasing at the rate of 4 centimeter. One is decreasing and the other is Okay, so we have to find out the rate of changes of the perimeter of the rectangle as well as the area of the rectangle. Okay, so what is a perimeter? What is a perimeter? Perimeter perimeter is equal to 2 into x plus y. Okay, and what is area? Area of the rectangle is equal to x into y, isn't it? So first we'll consider the perimeter. Let that p be the function. Okay, p we can differentiate it with respect to t. Okay, we are going to differentiate perimeter with respect to t. Okay, so that is dp by, we have to find out the rate of change in perimeter with respect to time, right? So dp by dt is equal to, what will be the answer? 2 into derivative of x with respect to t is dx by dt, and derivative of y with respect to t is dy by dt. So 2 into dx by dt plus dy by dt. So that is dp by dt. Okay, so this is equal to 2 into, what is dx by dt? That is given as minus 5, isn't it? Minus 5 plus, what is the change in the rate of change in the width of the rectangle, dy by dt? That is 4. So minus 5 plus 4. That is equal to 2 into minus 1. That is minus 2 centimeter per minute. Minus 2 centimeter per minute. Okay, now the second question was about area. You have to find out the rate of change of area of the rectangle when x equal to 8 centimeter and y equal to, x is given as 8 centimeter and y is given as 6 centimeter. Okay, so you have to find out the rate of change in area. So that means dA by dt, isn't it? dA by dt is equal to, and we know area is equal to x into y, which means you have to apply the product rule, right? So first into derivative of second with respect to t is dy by dt plus second into derivative of first with respect to t is dx by dt. Okay, so that is equal to x into dy by dt is dy by dt is 4 plus y into dx by dt. dx by dt is minus 5. So that is 4x minus 5y. It is 4x minus 5y. Now you have to put x equal to 8 and y equal to 6. Okay, so that is 4 into 8 minus 5 into 6. What is 4 into 8? 32. Minus 5 into 6, 30. Isn't it? 32 minus 30, that is 2 centimeter square. 2 centimeter square per minute. Since it is area, the unit of area is centimeter square. So it is 2 centimeter square per minute. All right. So moving on to our last question of the session. Prove that the function f given by, f of x is equal to x square into e raised to minus x is increasing. It is increasing in open interval 0 to. It is increasing in open interval 0 to. So what is f dash of x? What is f dash of x? F of x is a product of two functions, so you have to apply product rule. So this is first into derivative of second, that is e raised to minus x into minus 1 plus second into derivative of first. Okay, so this is equal to minus x square e raised to minus x plus 2x e raised to minus x. So this can be also written as 2x e raised to minus x square e raised to minus x. Okay, here you can take e raised to minus x and x common, right? So x into e raised to minus x into 2. 2 is remaining here. Minus x. 2 minus x. Okay, so this is our function f dash of x. Now what you have to do, you have to find out the critical point, since they have asked you to prove that the function is increasing in interval 0 to, right? So you need the critical points. For critical points, put f dash of x equal to 0, which implies x into e raised to minus x into 2 minus x is equal to 0. And we know that e raised to minus x is always greater than 0, isn't it? It is always greater than 0. It is always positive for any x element of R. You can take any x element of R, e raised to minus x is always greater than 0. So you need to consider only this part, that is x into 2 minus x. Okay, which implies x into 2 minus x is equal to 0. What is the reason? E raised to minus x is always greater than 0 for any values of x. Okay, so x into 2 minus x is equal to 0 implies that either x equal to 0 And the second option is 2 minus x is equal to 0, which implies 2 equal to x, isn't it? So x equal to 2 and x equal to 0 are the critical points. X equal to 2 and x equal to 0 are the critical points. Okay. Which means since this function, the domain will be the set of all real numbers, because here x can take the set of all real number. Here also it can take the set of all, x can take all the real values. So the set of real number is the domain of the function, which means the critical points divide the domain of the function into 3 intervals, isn't it? Which are those intervals? First interval will be minus infinity 0, and the second interval will be 0 to 2, isn't it? And the third interval will be 2 infinity, because x equal to 0 and x equal to 2 are the critical points of the function. All right, which means at x equal to 0 and x equal to 2, the nature of the function changes. All right, and here we have, in particular, they have asked about the interval 0 to. You have to prove that the function is increasing in 0 to. So you take any point from that interval. That is, you consider any point in between 0 to. Which is that point? Take 1. Okay, take 1 and substitute in f dash of x. So f dash of 1 will be, okay, 1 belongs to open 0 to. What is f dash of 1? F dash of 1 is equal to 1 into e raised to minus 1 into 2 minus 1, isn't it? Since this one is greater than 0, this one will be positive. The first one is 1, it is positive. Second one is always greater than 0, so it is positive. And the third is 2 minus 1, it is also positive, which means f dash of x is greater than 0 in the interval 0 to. F dash of x is greater than 0 in the interval 0 to. From this, what can you conclude about the nature of the function? What can you conclude about the nature of the function? The function will be, f of x will be strictly increasing in open interval 0 to. Since f dash of x is greater than 0, we can conclude that the given function f of x is strictly increasing in open interval 0 to. Okay, so that was the proof of the question. So we have discussed important questions that are asked in 2 and 3 mark session. I hope this session was useful to you all. Thank you.